Hey everyone, this is Rotomotion and Douglas GB coming at you again. This is season 1, episode 4, the promised RAM test section we're going to be going through today. So we will start a little bit in the setup area, and then we'll quickly go over to the RAM tab. So as always, one of us will be playing the role of you, I guess the student or the learner, and one of us will be playing the teacher or the trainer. And on the RAM section, that I will play the role of trainer, and Douglas will play the role of you, asking questions along the way. So let's get started. So RAM test. Before we jump directly into RAM, we we wanted to mention about grounding watchdog. And grounding watchdog is important both for RAM test and ROM test so that the board doesn't reset during the ROM or RAM test. So we failed to mention that in the previous episode, but we wanted to mention it now. So to ground your watchdog, you take a jumper, meaning a ground clip, like an alligator clip, and you clip it onto the section of the board that is usually named WDDIS, watchdog disable, and then the other side to ground. And on a space dual board that is pointing upwards, where the edge connector's at the top, that's going to be to the left side of a space dual, about 3 rows up, and then you can choose any ground on your board. And again, that's important to do before you do a ROM test or a RAM test. The watchdog disable is not really part of the FPGA cat box. Okay, now that that's over, let's jump into RAM test. So in the setup screen, under the RAM tab, you will see basically the section that gets loaded when you load your configuration file, and it will list locations, high to low bits, your ends, your addresses, your enable datas, disable after test, and things of that nature. Now, why would you want to do something like enable before test or disable after test? Those particular features were added when we jumped pretty deep into Williams boards, and you had to actually write data to the board before you could actually test RAM. So if I remember right, I think you had to write C800, you had to write an FF to C800 or C900, if I remember right, to actually test Williams RAM. And then, of course, you have to write a 0 to that same address after the RAM test is done. So that would be a practical use of those two parts of the setup. So that's enable before test and disable after test. And if you remember right, you can actually do that yourself in the config file. So you can manually edit that if you wanted to, or you can set that right here inside the setup. Okay, so let's go to the RAM tab.
But I'm not going to do it for Atari boards because you don't need like the Williams. Kind of shifted the mode from accessing ROM versus accessing RAM, but Atari doesn't do any of that. So for RAM tests,
Exactly.
right?
Williams board uses the same address space for some RAM and some of the ROMs.
Okay, and then let me ask you this: the location. I understand that E1 is literally where that chip is on the board, but why are there two here? Two locations.
There's two there. Is that, as some of you know, RAM gets tested in pairs, and on a space dual board, they're 4-bit RAM chips. So that's giving you locations from high bit to low bit, just like
High.
Douglas is pointing out there on the schematic.
Oh, so high bit meaning DB7, 6, 5, and 4 are E1, and then the other four low bits are H1. So that's why they're in that order, because it's E1 is high bits, H1 is low bits?
Exactly.
Okay.
Great question. Okay, if we can open the RAM test.
Oh, and then it that's also true for these other RAMs, which are vector RAMs.
Exactly. Yep, you can use that little slider up there to see your different locations. Okay, so if we go to RAM test, and you can choose if you want it to be on turbo mode or not. We discussed that in a previous episode. And right now we have it on turbo mode. And the most simple thing to do is, since this is all populated with the config file, is you can just start a RAM test. And you can see within a couple of seconds that it will do a full RAM test, and this board, which is good, passed all RAM. Now, just like the ROMs, you can individually enable and disable to the left of those lights there. You can disable or enable specific RAMs if you're going to be working on one specific RAM, and then you can restart the RAM test, got clear results, and restart the RAM test. And you can see you can pinpoint specific RAM to work on.
Nice. I only see H1 though. What happened to E1?
So if you go to location to the left of that and change the location to a 1.
These are bits. Your location for each bit. So I'm on bit 2.
So keep going.
Ah.
There you go. It will get to the next RAM chip based upon the location of the bit.
Ah.
By the way, this is really handy. Matter of fact, I'm working on a space dual board now that DB6, which is will be location 6 on this tester, is bad, and I wanted to know exactly what physical chip was DB6, and it of course told me it was E1. So that is a nice feature that Brett has given us to see the actual bit location of a failed RAM test. And trust me, sometimes you don't see the RAM totally fail. You'll just see different bits inside the RAM fail, which is extremely helpful in troubleshooting what's going on with that particular RAM chip. Sometimes it's not as easy as just replacing the RAM chip, because your data bus can be affected by all kinds of other chips around the board.
But that also tells you which, like if it is just one bit, it'll tell you explicitly which chip that bit lives inside of.
Exactly. And of course, remember, we're always counting from 0. So my example of DB6 is the 7th bit, but it turned out to be DB6. Okay, moving to the right of the screen a little bit. We went over. Oh, there you go. There's a good example right there.
Right. So what I just did was short pin 12 of one of the RAM chips, and it killed DB2. And because that's common to all, the data bus, if DB2 is shorted, it's going to affect not just this RAM chip, but anything that's connected to DB2. So that's why you saw it. And if I now change, like you said, change that to 2, it would. So if you got it for just this first line, you'd say, oh, it's probably H1. But like you were kind of saying, it could be a bus problem, and if you see that same bit failing in every location, then it's probably not just It's not H1 and K7 and J7. It is, maybe it's a buffer or something.
Yep, it could be. It's on the bus itself.
Yeah.
Exactly. Okay, so moving to the right side of the screen, we have covered the Start RAM Test button. Let's just quickly cover the clear results. So, often you will, repeat the results of a RAM test by turning on that repeat button. And one of the things that I do is I will say a clear result just to kind of clear that out so I can start a new RAM test and see new results. Just like that demonstration. Excellent. Okay, moving on, the RAM test type. This is a little bit tricky, but let's talk about that for a second. So the default is random, which is fine. You can stay on the default most of the time or all the time if you want. There's three others down here: sequential, FFF, then 00, and 00, then FF. Now, the useful feature that we have found with these other items like FF, then 00, is it goes through and will write FF to fill the RAM with FF, and then it will do 00. Now you may ask, well, okay, well, how is that helpful to me? Well, it's helpful in two ways. One way is that you know exactly what is being written to the RAM chip, and then what should be read back from that RAM chip, and you'll be able to see that in the RAM test status area. But if you get failures, it will also help you determine, is it a data issue or is it a bus issue? Because again, a lot of times when RAM fails, it isn't just a data issue, meaning a data bit issue. It's oftentimes a bus issue.
Like this one. So I just shorted DB2 again and to ground. So we're getting a 0. So the first pass, when it's writing a 0 and then reading back 0, it thinks everything's fine because, in fact, DB2 is always returning 0. But then the second pass, when you're writing all ones, you get back, and this is a little maybe confusing notation. The 1 here means that bit failed. This is not the data that you got back. It just means those other bits were fine, so I will not mention them. I will have 0 in there. But where there's a 1, it means that bit is wrong. So that 1 shows DB2, and that's on the second pass. So when it was, not when it was writing zeros, that was pass 1, but when it was writing FF on pass 2 is when the error showed up. And as you're saying, it's on every address. So this, because it's occurring on every address, it's a data problem, if that makes sense. If it were an address bus problem, then would be the reverse. You would have not every single address. It would only occur on addresses that weren't able to be created because there was a short on the address bus.
Exactly. That's a great detailed explanation of that. Thank you, Douglas. Okay, there's one more button that we want to mention, and then we'll conclude this episode. It is the Keep Errors button. Now, what Keep Errors does is it allows you to run the RAM test and keep inserting data stacked on top of each other, so it doesn't start over from scratch. And we haven't found a very specific reason to do that yet, but there is going to be a time where keeping errors and looking through the different errors with that scroll bar will become very useful. But that is what the keep error toggle does for you. Okay, so that concludes the RAM test portion of the FPGA cat box. I hope everybody found that enjoyable, and we will return with season 1 episode 5 next. See you guys later.